All right, so in this video, I'm going to do a review of chapter 4, which is basically quadratic relations. Now, I'm going to do this review pretty quickly. I'm going to take on a lot of questions and I'm going to do them pretty quick. So this is not meant to teach you these concepts rather than to just be a review of the chapter, maybe after you've completed it and you're reviewing for a test or an exam. I'm only going to review the important questions. I'm not going to cover all the concepts. I'm not going to do word problems, but basically I'm going to cover majority of the chapter and the important concepts. So the first thing we want to know in this chapter is how to use finite differences to determine whether an equation is linear, quadratic, or neither. So let's start with the first example over here. We have table of values and we need to prove whether this equation is linear, quadratic, or neither. So you want to find your first differences. The first thing you want to do is make sure your x values all go up by the same amount, and they all go up by 1 in this case, so that's good. For the y values, you want to find your first differences, which is basically your second value minus your first value. So 5 minus 4 is 1. Then your third value minus your second, which is also 1. This one's also 1, and then this one is also 1. So if my first differences are all the same, the equation is going to be linear. Take a look at this next table over here. So my first differences, 1, 3, we can already see they're not the same, 5 and 7. So if your first differences are not the same, you go to your second differences, which is basically doing the same thing on the first difference column. So 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2. If your second differences are all the same, the equation is quadratic. Let's try one last example over here. 1, 3, 5, 7, 9. So again, all our x values go up by the same amount, 2, 0, 1, 8, 27, 64. Let's find our first differences. 1, 7, 19, 27, 37, 37. And then over here, my second difference is going to be 6, 12, and then 18. So the second differences are not the same here. So this is neither linear nor quadratic. And if you actually extend this out, you'll see that the third differences will both be 6 over here. This equation is actually cubic, but again, you don't need to know that for grade 10. But we just know it's definitely neither linear nor quadratic. So that covers this concept. The next thing we want to go to is learning about transformations. Now, let me just talk about the equation of transformations in general. I'm not going to talk about it in too much detail, but we have 3 transformations in grade 10, and the equation is written like this. So the first transformation we're going to work now is with A, which is basically a vertical stretch or a vertical compression, and it's also a reflection in the x-axis. Okay, so we have 3 equations and we want to sketch them all on the same set of graphs. So we have y equals negative 3x squared. We have y equals 1 over 4x squared, and we have y equals negative 1 over 4x squared. We want to sketch all of these on the same exact graph. So let's do the graph over here. Let's start with y equals negative 3x squared. Negative means we're opening downwards because it's a reflection in the x-axis, and that's what happens if your a value is negative. 3 means it's a vertical stretch by a factor of 3, so the graph is going to be very tall and thin. So there's no transformations here in terms of left, right, up, or down, so the vertex doesn't get affected. You have a very tall, thin, upside down graph. for this one. 1 over 4x squared, that's a positive one, so it's going to open up. And 1 over 4 means we have a vertical compression by a factor of 1/4. If you have vertical compression, you squeeze something down really short, it becomes really, really wide. The graph is going to look like this for 1 over 4 x squared. Times 3x squared. And then negative 1 over x squared, 4x squared is the same as this, except it opens downwards. So that's how the a value affects quadratic equations. It just makes the graph thinner or wider, or basically taller or shorter, whichever way you want to put it. The next thing we're going to do is we're going to talk about this h value, which is basically a transformation left or right. So I have y equals x minus 9 squared, y equals x plus 2 squared, and y equals, right over here, x minus 5 squared. So I have three graphs. I want to plot them all on the same axis. So all these three graphs have the same a value of +1. They're all positive, so they're all opening upwards, and they're shifted left or right. There's a plus or minus inside the bracket. So let's start with this first one here, x minus 9 squared. Minus 9 means you shift the graph 9 units to the right. Remember your original graph, your original x squared graph is just like this, in case you didn't know this, but you should know it, that this is x squared, original x squared going to the origin. So I'm going to shift that 9 units to the right. It's going to be over here, and it's going to be just like the original, but shifted 9 units. X plus 2 squared is 2 units to the left. So -2, and again, same shape as this one over here, and -5 is 5 units to the right, so somewhere over there, and this looks like that. All right, so pretty simple with that one over there. Next one is we're going to work on this k value, which is basically a shift up or down. So first equation is y equals x squared plus 8. Second equation is y equals x squared minus 5. And last one is y equals x squared minus 10. So x squared plus 8 is just the same as x squared, except it's shifted 8 units up because that plus 8 is outside the bracket. Let's put that over here. It's positive. X squared minus 10 is just shifted down by 10 units. Same exact shape as this one though. You know, it looks maybe slightly wider, but it shouldn't be. And x squared, oh, I did the last one, minus 5 is over here. Okay, and that's that question over there. And then you just have to know how to do transformations in combined questions. So, and you have to know how to describe transformations as well, but I'll do them in some more complicated questions in terms of describing the transformations when we get to full equations. Okay, so next thing you want to do is you want to have combined transformations for all of these questions. So let's take a look at some of these examples over here. Pick a couple of them. Start with something a bit easy. So y equals x minus 2 squared minus 4. So we need to do a couple of things on this question. We need to know how to plot this graph and do the axis of symmetry, the vertex, all those kinds of things. So let's get started. The first thing when you look at this is the a value is +1, so it's going to open up. The x value of the vertex is +2 because this is shifted 2 units to the right. The y value is -4. So my vertex is over here, and I know this opens up. I'm just going to sketch it like that. Intercepts are not important to get them accurate in these sketches. 2, -4. So that's my sketch. And then that's my axis of symmetry right there. Basically, it's symmetrical about that axis, and it's going to be x equals to 2, just the x value of your vertex. This graph has no stretch or compression. Like I mentioned, the direction of opening is up, and for your values that x can take, well, x can take any value because this goes to the left forever, this goes to the right forever, so x can take any value. And what about y? Well, y has to be greater than or equal to -4, because -4 is the lowest possible y value, and y has to take any value equal to or higher than that. Let's take a look at another example. Y equals 1/2 x plus 1 squared plus 5. Let's do the same procedure for this one. So the first thing I notice is that the a value is 1/2, so it's positive, which means it's going to open up, and it's got a vertical compression of a factor of 1/2. This number, if your a value is less than 1, it's a compression. If it's greater than 1, it's a stretch. So since this is less than 1, it's going to be a compression. The graph is going to be shorter and wider. Let's take a look at the vertex. X value of the vertex is -1. The y value is +5, so somewhere approximately here. This graph opens up and it's a little bit wider than a regular x square graph. So that's what it looks like. No, not perfectly symmetrical, but you get the idea. Probably should draw it in pencil and you're doing it on a test. Okay, we know that the x values for this is going to be any x values. There's no restrictions, but the y values have to be greater than or equal to +5, because y is above +5 the whole time. And let's do one last example. Y equals -3 x plus 4 squared minus 2. Okay, so this one, again, the first thing we notice is the a value is negative. So this graph is going to open downwards because there's a reflection in the x-axis. It's vertically stretched by a factor of 3 because this number is larger than 1. You don't look at the negative when deciding whether it's a stretch or a compression, just the value of the number. And then the x value of the vertex is -4, and y value is -2. Remember, we flip x values, we don't flip y values. And I know this is going to be very tall and thin because it's got a vertical stretch by a factor of 3. So it looks something like this. I've got the axis of symmetry for the last one. It's just x equals -1. And over here, the axis of symmetry is just x equals to -4. The x values, again, are anything for this one. That's true for pretty much all quadratic relations except for word problems. And the y values, in this case, the graph is going down, so y has to be less than equal to -2. The sign flips backwards. Greater than equal to is when you're opening up, less than equal to is when you're opening down, because your y values over here are lower than -4. Okay, next thing we want to do is we want to be able to write equations given key features of the graph. So let's do a couple of examples of this. There's quite a few different ones. There are simple questions that tell you the vertex is -3, 0. The graph opens down, and you have a vertical stretch by a factor of 2. So this is a pretty simple equation to write because we know that our a values are vertical stretch. We know that if it opens down, the a value is negative. So we have -2 over there for our a value. We open a bracket because we have x value of the vertex. So that's going to be x plus 3 squared, and then plus the y value of the vertex. But since it's +0, I don't need to write +0 over here because +0 does not mean anything. So that's my equation there for this one. And let's try another one. We have The vertex is 4, -1. The graph opens up and we have vertical compression by a factor of 0.3. Again, this one's pretty simple. We're opening up, so it's positive. Our vertical compression is 0.3. X value of the vertex is 4, so we have x minus 4. Close the bracket, squared, and y value is -1. So we have a -1 out there. So just backwards from the steps we were doing a bit earlier. Next type of question is a bit longer. Same thing, we're finding the equation, but now we're given a graph. You need to find the equation from the graph. So the graph we're given is a quadratic equation that looks something like this. We have a point here, 0, 11, and we have the vertex here is 4, -5, and that's all we're given in this one. So whenever you're given like this 2 points on a graph and you need to come up with the equation, you just want to start with the basic equation, x minus h squared plus k. I want to start by filling the vertex in this equation with your h and your k. So y equals a x minus 4 squared minus 5. And then you want to sub in the point they give you and solve for a. So my y value is 11 and my x value is 0. And now I want to solve this equation to find my a value. That's just -4 squared. -4 squared is 16. I'm gonna add the 5 on this side. So I'm gonna get a equals to 1, which is a bit easy in this question. We got lucky with this one, a equals to 1. Hopefully the other one won't be the same. So when I rewrite my equation, since my a value is 1, I don't even have to write the 1 there because 1 times anything is the same thing. So it's just x minus 4 squared minus 5. Let's try another one over here. Do a second one for practice. So that's what our graph looks like. This point is 4, 13, and this is 6, -7. So I'm gonna do the same thing. We're gonna start with subbing in the vertex, x minus 6 squared minus 7. Then I'll sub in the point 4, 13 into this. So y is 13 and x is 4. That's -2. -2 squared is 4. And then divide by 4 on both sides. So I get 5 for my a in this one, which is good. And actually write it. So I'm going to rewrite this equation here with the a value that I found, 5x minus 6 squared minus 7. And the next type of question is pretty much identical to this, except instead of a graph, we're given points. So it gives us a vertex of 2, -2, 5, and it tells us that the y-intercept is 1. Now you could just do a sketch of this, but why waste your time with a sketch? We're following the exact same procedure here. I'm going to start by subbing in the vertex into this equation. So y equals to a x plus 2 squared plus 5. Remember to always flip the thing for the x value here. Then y-intercept of 1 means y is 1 and x is always 0 at your y-intercept. Just have to solve it. I get -1 equals to a. I'm going to write my equation as y equals negative x plus 2 squared. You don't need the 1 plus 5. Okay, and a lot of word problems like this as well. But like I said, I'm not going to discuss any word problems in this video. So the next thing we want to learn is how to sketch from factored form. We've been sketching from vertex form, which is basically transformation form. But now we're going to sketch from factored form. So let's try a simple one to begin with. Let's start with y equals x minus 6 times x minus 2. So this is factored form right over here. I can tell that my zeros are x equals to 6 and x equals to 2. So let's do this sketch really quick. It's also a positive a value out here, which means that it's going to open upwards. So 2, 6 opens upwards. Should look something like this over here. Now I want to find my vertex, and to find the x value of the vertex, I have to find the midpoint of these two. Now it's pretty easy to tell it over here mentally, but I'm going to show you the calculation over here. You're just adding your two x-intercepts and dividing by 2. Just positive 4 for the x value. For the y value, you want to sub it into this equation. So I have y equals 4 minus 6 is negative 2, and 4 minus 2 is positive 2. Negative 2 times positive 2 is negative 4. So the vertex is 4 and negative 4. Let's try another one. Over here, we have y equals negative 2, x minus 4, x plus 2. So again, similar idea. I'll state your zeros first. X equals to 4 and x equals to negative 2. So positive 4, negative 2. This is a negative graph, negative a value, so it's going to open downwards. And then to find the vertex, we'll do the midpoint again. So negative 2 plus 4 divided by 2, that's my x value, which is 2 over 2, which is positive 1. And for the y value, I'm going to sub it in to the equation over here. If I sub in positive 1 into this equation, I have y equals negative 2 times 1 minus 4 is negative 3. 1 plus 2 is positive 3. So negative 2 times negative 3 is positive 6. 6 times 3 is just 18. So this point is 1 comma 18, and that's the sketch of that graph over there. All right, next thing is we are going to find the equations from a graph. So they give us a graph. Looks like this. I should have probably drawn the axis. That's a really bad graph. I don't know why I drew it like that, but it makes sense. Negative 3, negative 7, and they give us a vertex, which is negative 5 and negative 2. So this is writing equations in factored form. They specify to do this in factored form. So our equation for factored form is y equals to a, x minus r, x minus s, where r and s are the x-intercepts. So similar idea, you want to start with subbing in your x-intercepts into this equation, which are negative 7, negative 3. So I have y equals to a, x plus 7, x plus 3. And now I want to find my a value by subbing in another point. So I'll sub in the vertex here. The y value is negative 2, and the x value is negative 5. And now I'm just going to solve for my a value. I get my a value to be 1 over 2. So my equation is just y equals to 1 over 2 x plus 7, x plus 3. So very similar to what we were doing earlier, but now we're in factored form. So this is pretty simple. I'm not going to do another practice question for this one because it's kind of the same procedure. And then we go to our last topic, and this is actually going to be exponents. This is the only exponents that's covered in grade 10 math, and You can do this with and without a calculator, but I'm going to do it without a calculator because in grade 11, you'll be expected to know how to do these with letters, and you cannot use letters or put variables in a calculator. So technically, you should just know how to do each of these in without a calculator. So let me start with just some basic ones. I'm going to go through quite a few exponent questions here, and that will end this video. So we're going to start with basically simplifying each exponent. So the first question I have is 3 to the negative 2. If you have 3 to the negative 2, it's just going to simplify. The first thing you want to do is get rid of the negative exponent. So we're going to bring it to the denominator and make the exponent positive. And then 3 squared I know is just 9. So my final answer is 1 over 9. Pretty simple. If I have 5 to the power of negative 1, that's just 1 over 5 to the power of 1, which is just 1 over 5. So nothing complicated over there. Sometimes you can have brackets that makes things a bit harder. So if I have negative 2 to the power of negative 4, I'm going to get rid of my negative exponent first. So that's 1 over negative 2 to the power of positive 4. Negative 2 to the power of positive 4 is positive 16 because a negative times itself 4 times will turn positive. Negative times negative is positive times negative is again another positive. So if you have an even exponent, negative numbers will turn positive. If you have an odd exponent, negative numbers will stay negative. Okay, and last from this one, negative 7 to the power of negative 1 is just 1 over negative 7 to the power of positive 1, which is just 1 over negative 7, which is basically negative 1 over 7. You can't have negatives left in the denominator as a simplification rule in math. Okay, next one is going to be 9 to the power of 0. Now, any number to the power of 0 is always just 1. That's a very important rule to remember. It'll show up quite a bit. And next one is, let's see, I have negative 3 to the power of 0. And again, negative 3 whole power to 0 is just 1 as well, because if there's anything inside a bracket and the power outside is 0, it just turns to 1. And last one is negative 89 to the power of 0. So this one is actually going to be negative 1 because the 0 power only applies to the 89, not to the negative sign. So the negative sign stays the same, and 89 to the power of 0 is positive 1. So make sure you note these differences in these 3 questions and how this works. Pretty easy marks. It's not a trick question. And then last but not least, we got to do some fractions with the same rules. So we'll start with 1 over 3 to the power of negative 2. So I first want to get rid of my negative exponent. I just have to flip this upside down. If I flip it, it's 3 over 1, which is just 3 to the power of positive 2, which is just 9. Okay, let's say I have negative 1 over 4 to the power of negative 1. If I flip this upside down, it's going to become negative 4. Don't get rid of the negative on the inside here. Only get rid of the negative in the exponent. Negative 4 to the power of positive 1 is just negative 4. Let's say I have 5 over 6 to the power of negative 2. I'll start by flipping this. So this is going to be 6 over 5 to the power of positive 2. And then I'm going to square this. So 6 squared is 36 and 5 squared is 25. So that covers basic questions. Then you have some slightly more advanced exponent questions, but they're not too difficult. You have like something like 6 to the power of 0 plus 6 to the power of negative 2. And we just have to evaluate this. So we know 6 to the power of 0 is just 1, and 6 to the power of negative 2, well, that's 1 over 6 square, which is basically 1 plus 1 over 36. Now we have to add these. So I have to make a common denominator over here. This is basically 1 over 1. We're going to multiply the top and bottom by 36. So I have 36 over 36 plus 1 over 36, which is 37 over 36. Next one is 8 minus 8 to the power of -1. And 8 just stays the same. This is going to turn into 1 over 8 to the power of 1, which is basically 1 over 8. Need to make a common denominator here, so I'm multiplying the top and bottom by 8. So that's 64 over 8 minus 1 over 8, which is just 63 over 8. Next question, this is almost a trick question. It's just 4 plus 3 to the power of 0. Now you can automatically tell the answer is going to be 1, but if you want to simplify first 7 to the power of 0 and then write 1, it's perfectly fine as well. Then 4 to the power of 0 plus 3 to the power of 0. 4 to the power of 0 is 1, 3 to the power of 0 is 1, and 1 plus 1 is 2. So again, pretty simple questions, but exponents do get harder in grade 11. You'll see the majority of the bulk questions over there, which have a lot of different letters and numbers, and it gets a bit more complicated. And last question for this video is going to be solving exponential equations. So first question over here, I have x to the power of -3 equals to 1 over 27, and I need to solve for x. So if you have to solve for a letter, you want to make the exponents the same so you can cancel the exponents out. So x to the power of -3, I'm going to turn 27 into 3 cubed. And then I'm going to move this to the top. So x minus 3 equals 3 to the power of -3. So now that my exponents are the same, when I move to the top, the exponent just becomes negative. Now that the exponents are the same, I can just cancel them off, and I know that x equals 3. That's how you solve exponential equations. I'll do a couple more examples. X to the -1 equals 4 over 5. So I know that if I go x to the -1 equals, and if I flip this upside down and make it 5 over 4, my new exponent is going to be -1, because over here it was +1. If I flip it, it becomes -1. Exponents are the same now. I can cancel them off, and I'm just left with x equals 5 over 4. Don't need the brackets anymore. Third one, we have 2 to the x equals to 1 over 4. So I'm going to first turn this into 2 squared. Then I'm going to move it to the top and make the exponent -2. In this case, the bases are the same, so I can cancel them off. Unlike the last two questions where the exponents were the same. So x is just equal to -2. And last question of this video, 2 over 5 to the power of x equals 125 over 8. So I know that I can actually convert this to 5 cubed and this to 2 cubed. And then I can write that actually as 5 over 2 to the power of 3. And then I just have to flip it upside down to match the base over here. If I flip it upside down, my exponent becomes -3. And bases are the same, cancel. I'm just left with x equals -3. So that is a complete review of chapter number 4. I know I didn't do any described transformation videos. That might be another important topic in this chapter, but I don't know why. Maybe there's some questions that I can cover for describing transformations really quick. Yeah, there are a couple of questions. I mean, I technically did describe them in terms of words, but I never wrote them down. But I think I've pretty much covered everything in the chapter here. So if you enjoyed this review and found it helpful, please like and subscribe. Thank you.